the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
The Stevens Institute of Technology is proud to present the Hugo New Corporation Sustainability Seminar Series, brought to you by Brown and Codwell, Geocetic Consultants, H2M Architect and Engineers, BEM Systems, and Catalyst Group.
Thank you, and very complimented, Dibs, because I was mentioning to my friends and colleagues, Mike and Sandy, that this group the class is always very impressive, and for all the challenges that we have today, I feel like we're in good hands in terms of the talent at Stevens and in these classes. So want to thank you and Samir, and thank the class for having us again. I also want to thank my co-presenters, Mike Hertzberger and Sandy Hertz. We were reminiscing because we all go way back. There's that what's that Henry Ford quote, coming together is a beginning, keeping together is progress, and working together is success. And I don't know, there's probably like a fourth dimension for us, because we've not only continued to find reasons to work together, we're still collaborating, but we genuinely enjoy and appreciate each other. And I'll ask Mike and Sandy to maybe say just a few more words of what you want to share about yourself. Mike Hertzberger is Division Chief of Geospatial and Engineering Services for Maryland Environmental Services. Sandy Hertz is Assistant Director, Office of Environment for Maryland Department of Transportation. That doesn't really begin to tell you guys how innovative, speaking of disruptors, and also, Maryland Environmental Services is quasi-government. They're kind of an interesting org, and Mike, you can say a few words when you speak, but I worked with them when I was at EPA, and looking for better ways to do good government. And, I must say, you don't always find someone that's willing to go for the wicked types of challenges. Those that have so many different dimensions, it's not really easy, but that it is a major issue that impedes progress. Not only that we can do better. And that's where, we all met. Sandy and I actually many years before that. I think I was 15, you might've been 12. And there was the historic issue of what I called sort of the Hatfield and McCoys, were the resource agencies such as EPA, where I was, and the departments of transportation. And, constantly hearing, because of the resource regulatory agencies, that we were creating barriers to moving big projects along, because we had so many different demands and requirements were never very clear. On the environmental side, it was, big transportation wants to just come in and, move everybody aside. And, get their projects out. And we realized that, the two actually coexist. First of all, it's all within the public interest. It is all necessary. And it was the environmental people, because these were the NEPA type folks, along with regulatory folks that were doing this. And we had found a way in the Mid-Atlantic, MATE, remember that, Mid-Atlantic Transportation Environment, to work together, figure out how to do that. In fact, to some extent, we started giving each other proxy at certain meetings, and we streamlined 8 to 11 regulatory authorities. Now, this is all about transferability. And I'll tell you, I moved around with EPA, and I moved to Region 6 and was working with Big TxDOT. I remember the first time I sat down TxDOT, I said, tell me about your projects. They said, which ones? Because our regular projects are the $3 billion. And then we have the special projects. Well, it's Texas. And I worked with them, and there was a huge project, International Border Project, NAFTA, that they wanted to streamline. And I took our process, transferred it to Texas, which they adopted, and streamlined that project. And we created a GIS-driven support tool. That was the first iteration. Came back to Region 3 and said, hey, I think we can take what we did to the next level. I never realized it was going to become what you will hear about today, that being way beyond transportation, where even just recently, Mike and I are talking about how to fulfill and retrofit different types of existing infrastructure like ponds, create sensors in them, and use this tool to take note of how much volume can be addressed in a storm that's coming in, as well as accounting for carbon credits, ESG alignment. I mean, we will have conversations after this. So that's my introduction of Mike and Sandy, and when they speak, I'm going to leave them free to share additional aspects of what they do and their priorities. So we're talking about what we call the Watershed Resources Registry, and what is it? The definition: web-based, user-friendly mapping application encompassing multi-agency collaboration designed to achieve regulatory streamlining by scoring sites to promote sustainable watershed restoration and preservation. Well, what does that mean? And this is online. You got this web address. You can check it out later on your own, and you'll find that it's very useful because of all the additional base layers Mike will talk about. Sorry for the busyness of this screen, but this gets to some of the points I was making earlier. In terms of looking at big projects like highway projects, and trying to decide, not only what the best alternatives are to reduce impact, but the concern was also about permitting, and how long permitting processes were taking. So this was how can we take, starting with the Clean Water Act, all right? So you've got 401, 402, 404. I don't know if you guys know all those, but the 404, for example, wetlands, 402, stormwater, and 319, was non-point source. These were all, these are all related to resources, for example, in the same watershed. But here, because of these different statutory authorities, we had compartmentalized everything. So we saw where, our actions were really just being driven by the administrative requirements under that section itself, without sort of getting back to the watershed and the resources and the science of what needed to be evaluated more holistically. So this was an effort, and our backs could be to each other. I could have been coming from a Clean Water Act, the surface water streams, ecologically sensitive streams, and then you've got our wetland folks in another department, and we can't move past ourselves. So how do we go back to that watershed, that ecosystem, and have it drive how we use the tools in that toolkit called the Clean Water Act? Because we're going to be more successful that way if we know where wetlands were, for example, and they've been filled. And we target those areas for restoration. So that's a simple example to give you an idea of what this concept was about, and then how we can then become good government. So this provides an integrated and transparent platform for accomplishing that, starting with what data do we have? Each resource agency, whether that's the Corps of Fish and Wildlife, EPA, NOAA, et cetera, have responsibility for different, I'll say, custodians of different resources that we protect, some overlapping. What do we consider to be the best data? And the next step was, how do we make that information not only available, but weight its importance as we see it from being responsible as resource agencies relative to restoration, preservation, enhancement, and make it available, fingertips. Like I said, but the IRS could figure out how we can all do our taxes online with different kinds of information very quickly. Why couldn't we figure this out in terms of the regulatory processes and permitting? And what we also found is, while we came together collaboratively, we agreed it could be better, we can do better, we all care about these resources. We found that after creating it, it drove collaboration where it had not existed before. And it has continued to evolve as the applications have evolved and as the integration of information has evolved. So I just mentioned, this came out of something we call the Green Highways Partnership. Maryland has been a leader. They stood up and said, we want to try this. And then the framework went from there. So I'm going to go real fast and then turn this over to Mike, because I'm sure you want to see this incredible system live. So it's watershed approach, preservation and restoration of natural resources, multiple meanings for registry. At the time, I actually was able to name it Watershed Resources Registry, because the idea was, once we identify these sites as opportunities, whether it's upland, whether it's, we're looking for mitigation for wetlands. And then we wanted to take it to stormwater. That came later. That was a lot harder. But think of a pressure state model where you're looking at a watershed, you're identifying the vulnerable receptors, right? The environmental receptors, and you're looking at stressors. That's sort of the idea, but it was working with many experts and also the regulators, their scientists, others, to figure out, how do we do that? And what data layers do we have confidence in? So it wasn't just like when you pull a GIS map up and you can put all these layers out. You want to know, okay, what's important in that layer if I'm applying for a wetland permit, or if I'm looking for the best ways to address my requirements under a 402 permit. So, screening projects, mitigation sites, and so that we wouldn't count it double, like we're seeing some concerns with carbon offsets. The registry then says, here's what's available that hasn't been used yet, for what purpose. So it also became an accounting system. But once there was information on that site, and Mike actually took it to the app stage, and you'll hear exciting things. There was ability to use this information if you're looking at properties in that area or nearby. So avoidance, minimization, mitigation, and it wasn't just for transportation. This was for municipal county planning projects. And now we've moved on beyond even looking at sea level rise and floodplains and things like that. So you just seen, I've just mentioned these kinds of things. It's also now being launched in a number of states, increasing interest. And it is defined by that state because we're talking about that, the ecological watershed resources in that state. In fact, it is being developed in New Jersey as we speak. And I know there's interest, of course, in climate and flooding and those kinds of things. So, it's really nice when you see an original tool be able to adapt and be focused on, be able to adapt to the priorities of that place. And it integrates transparent mapping as well. So those are some of the states that are using, as I mentioned, New Jersey, South Carolina, Alaska, Mid-Atlantic is there. And that's what I worked on with Mike and Sandy, was making sure all our Mid-Atlantic states were using it and adopting it. So in terms of the analyses, these are the suitability models that were incorporated: wetland preservation restoration, riparian zone preservation and restoration, terrestrial habitat preservation and restoration, and natural what we call for stormwater. And we didn't want areas where hydrology was intact, like conserved areas, competing with those that have been fragmented and built out like urbanized areas, because otherwise you're always going to be going to the other areas and you're not going to address what could be improved in that built out area. And we know that, right? We know that with retrofits and green infrastructure. So how do we use this tool to target those areas based on that land use? Don't expect you to read all that. Just, it gives you an idea of the weighting system and how the model actually works. Mike's going to take you through some of these examples, but all of this was a lot of vetting, lots of vetting by a variety of experts. And what's kind of nice though is peer counseling. So we know if EPA had a certain perspective in one part of the country, it was consistent with perspectives in others. Same thing with Corps and DOTs, et cetera, or certain types of expertise. We've beta tested it for those sites that come up high for a certain target practice. On the ground, we found it is consistent and it fits. So we're just very pleased to be able to share it. So I'll just, here's a stormwater example. What I wanted to do, some models actually, you have to tell them where to go first, and then they evaluate the best BMP to get the best result. What we wanted to do was say, no, we want to take a region, a sub-watershed or watershed, and we want the model to tell us where to go in that watershed because it's watershed driven. Then we want to be able to drill down in that area or those areas to say, okay, now that you got me here, what's the best thing to do where if I'm going to address, for example, stormwater? So here's an actual analysis from the watershed, took us to a corridor. You see the area in blue, then you see that lighter blue that actually gives us a smaller focus area for the BMPs. Prince George's County, you've heard about the community-based P3 partnership. We did this webinar. They actually are using it and have found that it matches. And you can see the scale percent of projects where they found most suitable 30%. The WRR was key in being able to expedite, and they liked it so much they now use it. So here's another example of where you can not only take it to a smaller area and you can also identify that based on that practice. For example, here it's 45 acres of drainage. How much nutrient reduction you can get by using a pond as a BMP. And you can look at the estimated cost. So now think about how valuable that is from a decision-making standpoint. So with that, here comes the really exciting piece. But you know, Sandy's gonna really like bring it on home, because that ferret's gonna pop right over when you talk. Over to Mike, and I'm gonna stop sharing my screen so you can see that.
Excellent. Well, hey, thank you, Dominique, and it's a pleasure to be here. I want to thank everyone for the opportunity to talk about my favorite project here, which is the Watershed Resources Registry. Again, my name is Mike Herzberger. I am the Division Chief of the Geospatial and Engineering Services Group for Maryland Environmental Service. Quick soundbite on MES. We are an independent, not-for-profit state agency of Maryland. We're not a resource agency. We're not a regulatory agency. MES is a service agency, and we support state and local partners solving environmental challenges of all shapes and sizes. So I tell you what, why don't I go ahead and just jump right in? I've got a lot to show you. I tend to talk fast. The good news is everything I'm going to show you is available in the public domain. And my hope here today is to really give you guys a flavor of what the WRR is all about. And it really comes down to what hat you wear, right? What questions you're trying to answer. So I'm going to go ahead and try to share out my screen here. And let's see, can you guys see the homepage of the WRR right now?
Yes.
We can.
Outstanding. So you can attach, or you can fire up the Google machine and search for Watershed Resources Registry. It'll take you to our homepage, and it gives you a quick synopsis of what it's all about. You saw the graphic there of what states have already currently adopted a WRR. And of course, our goal here is to turn all of these gray states green, including New Jersey. So I do want to apologize. I think we probably missed it by 2 or 3 weeks from go live to Jersey. So check back, because at some point you're going to come down to New Jersey right here, and what you're going to find is that the coming soon sign will be gone, and the data will be published and available for everyone's use. Under each state registry, we also have points of contact available. And so I'm going to demonstrate Maryland, but the overall functionality of the application is pretty much consistent throughout. And so one of the things that I know that Dominique shared with you guys quickly was the spatial analysis. And so the interesting thing here is that, you know, we tried to be as transparent as possible as a technical advisory committee, hammering home what were those relative and absolute factors. We wanted to go into any one of these models, right? Absolute and relative factors. So absolute, it's a have to have. Relative, it's a nice to have. And basically we did a spatial analysis, a 30-meter resolution raster-based analysis, an overlay analysis. And from there, we were able to rank those sites. So what you're seeing right here is the actual application for the WRR. If I click on this little button here, I can expand and see all the data that's inside. Now, I haven't counted it in a while, but I'd say in Maryland, there's close to a ballparking 150 layers. And these are all the data layers that our resource and regulatory partners, state and fed, use to inform decision-making in terms of screening projects and evaluating projects for any number of reasons. So as you can see, there's a lot of data in here. And what we can do is we can quickly turn on and off any one of the model outputs. And of course, it doesn't look so impressive when we're looking at this scale, but if I go ahead and pick on, for example, wetland restoration and zoom in a little bit, I can begin to see where there are opportunities across the landscape to restore wetlands. And so we can sit here and toggle data on and off forever. And it's a useful thing to do, right? But ultimately, you know, we find instances where, you know, we just need to find areas where we can go and do mitigation. I need to find an area to go and restore wetlands for ones that I'm going to impact. And, you know, normally what we would do from a regulatory side is we may start looking at U.S. Army Corps of Engineers rivets data, right? So this is wetland banking data. And so we could see that, well, you know, I've got some areas where there might be some potential banks. I've got some areas where there aren't. The key thing to take away here is that the bulk of this data does not live on MES servers. Actually, much rather, we're actually integrating with other servers and folding that data into our servers. So when the application refreshes, we're always receiving the latest from the original data custodian, whomever that might be, fed or state, and that's across all 8 states. So it allows us to be able to go and ensure that what we're looking at is the latest and greatest, and it also offsets the burden of having to host terabytes of data on one server just to stand up this application. So this idea of deep linking comes to mind, right? That term, we're going to apply a couple of different ways, because we can also look at deep linking to actual data itself. And so if I start to go and interact with some of this data, what I can find out is information about an actual bank, right? So if I click on this just right, I can find out information about the service area. I can also deep link back to the U.S. Army Corps of Engineers Ribbit site and find out more about wetland banks that might be available. Here it is right there. Sometimes it likes to get a little finicky, but this is the actual wetland bank. And so if I was an applicant and I was going to have impacts to a wetland or aquatic species, I can use this and potentially buy credits to offset those permit impacts, right? So let's just hypothetical though and say I'm in one of these areas where there are no banks, right? Which does happen. This is where the WRR can also plug in. And so under the wetland restoration layer here, I'm just going to go ahead and zoom in just about anywhere, and we can do what I like to refer to as the hunt and peck method. I could turn data layers on and off, every permutation under the sun, right? But one thing we realized was it's so much data. It sure would be helpful if we could just ask the database a question, right? If we could just ask this data a question. Some of these outputs actually have over 1 million records in them. So it's a lot of data. And if you look at the table of contents, you'll see it's a 1 through 5. The darker the color, the higher the score. The higher the score, the more relative factors, the more nice to haves were geographically coincident for that location on the Earth. Whatever those factors are, they're all different for every state, for every model. And that's really what the technical advisor committee really honed in on, was locking down those requirements, right? And so rather than me try to search 1 million records here just by, eyeballing and doing the hunt and peck method, a much easier way is to use the find opportunities tool. And so I can come in here and I can actually run a query, and from there, off I go. So let's say I'm interested in Carroll County, and I'm going to look at a particular watershed. I'm going to look at the Upper Big Pipe Creek watershed, and I'm going to look for a wetland restoration opportunity. And you know what? Again, higher the starburst that you see here, if you will, the greater the outcome in the sense that there are more relative factors, again, geographically coincident, relative factors that are of value to our resource and regulatory partners. So I'm going to look for this 5 area, and I'm going to look for anything greater than or equal to 1 acre, and I'm going to click search. And so what's happening right now is the query is running in the background, searching this particular data set and returning back those particular sites. And so if I close out my little query dialog box, you see that it zoomed me to those extents. Well, I can select any one of these records. And I can also, maybe I want to go and sort descending because I want to go to the biggest site. That's the one that I'm most interested in. And so I click zoom to, and voila. I know I have a 5-star site right here that might be a good fit for me and what I'm trying to get accomplished. So again, this is a great opportunity for me to start to turn on and turn off additional layers and give you guys just a little flavor of what we have in here. Just a ton of information. Water quality data, you name it, floodplain data, sea level rise data. Here's some NHD flow data. It's fed, it's state, it's everything our state and resource and federal resource and regulatory agencies said that was of value to them. And so again, I could sit here and toggle on and off forever, but we realized again that there's a better way. And that's when we invented the location details tool. And so this tool is customized for each and every state. The information that gets returned is unique to each and every state, with actually some consistencies, right? So follow me through here. I'm going to use this little extent tool here, and I'm just going to draw a box, right? Okay, so that's my area of interest right there, right? Give this a second. And of course, my daughters are running on the Wi-Fi. I'm sure they're streaming right now. So God willing, this all works for me, right? You'll see that I have a NEPA Assist report and a WRR report. When I click on NEPA Assist, what's happened here, and I'm going to click on WRR too, I just ran 2 different reports. If you noticed, I'm now on an EPA website. It took the coordinates, that little envelope, that user-defined extent I drew on that map, and it basically took those and dumped it into this report from NEPA Assist, and it gave me the report. As if I was running NEPA Assist, found the location, drew the box in their app, and then asked for them to run the report. The other thing it's done is it's given me access to additional reports. So, for example, this IPAC report, this is a report that U.S. Fish and Wildlife provides, and it's already integrated inside of NEPA Assist. And I can find out about endangered species, and this is the same exact location. Again, I drew the spot one time. I can also come in here and look at demographic data, census data, EJ data. So this actually integrates with the EJ screen tool. And I can get, again, the EJ Screen Census 2010 summary report and some additional summary reporting out of the EJ Screening tool and the NEPA Assist. Oh, and let's see, come back here. It's thinking about popping back up. We'll give it a second. The actual location details report actually runs as well. And what that does is that gives us a complete representation. It's churning figures, gives us a complete dump of custom reporting that the technical advisory committee decided was most important to them. So a couple of other things that I wanted to show to you guys to give you a little bit more perspective was a case study. So Dom was very clear about the fact that stormwater was something that was a focus for our partners. And what I want to do is pull an example here of where we've gone and we've done that. Give me one sec. Get back to my spot. Here. So this is a case study we did for Pennsylvania. We looked at the stormwater restoration model outputs, specifically in the Willis Run Codorus Creek Watershed, NPA, and took it a little further beyond just identifying where areas across the landscape may be suitable and looked at actually identifying what kinds of BMPs might be appropriate. And so this is a story map that we can share out via link after the presentation, and I'm not going to read the text all to you. Again, we'll be happy to share the link with you, but a little bit of description on the watershed, using the WRR, how we queried for that data, looked for certain opportunity outputs. I think it was like a 3 or higher, and began to then evaluate what was possible within that watershed. These are the absolute and relative factors that went into that particular model. This is us running that query here. And again, looking at what these outputs are telling us, estimated drainage areas, and then pounds of nitrogen, phosphorus, and sediments that we could potentially move. We even also looked at initial cost of each BMP site. And this basically steps us through some of those sites. Interesting how we were able to go and use it. And again, we found a lot of places in right-of-ways that we could potentially look to do some sort of natural hydrology. Some of these sites were, I think, a little bit more exciting to our partners than others. But we definitely found opportunity and correlation with the outputs that the TAC came up with versus where it is that we're recommending to go and consider spending some money to reduce some pounds of nitrogen, phosphorus, and sediments. So let's see. I do want to be sensitive to time. I know my colleague, Ms. Sandy Hertz, also has some wonderful things to share with the group. One thing I did want to mention just quickly is I also am the co-chair of the Emerging Professional Working Group for the Maryland State Geographic Information Committee, and we have recently gone through an EPA Industry Professional Talk series. It's a 5-part series of interviews. They're all online. It's free to access, and anyone that's interested in learning a little bit more about perspectives of using GIS for engineering and environmental, highly recommend taking a look at the series. It's out there, and I'll share that link. So with that, Sandy, if you're ready, I'd like to pass the torch and let you bring us home.
Yeah, it was the share screen button that was bothering me right now. Can you see my screen now?
Yes.
Yes.
So as far as you all know, I'm completely living up to Dominique's expectations of inviting me to today's presentation. So she wanted us to share a little bit about ourselves as we introduced our sections of today's presentation. As Dom said, I'm Sandy Hertz. I'm with the Maryland Department of Transportation and their Office of Environment. A little bit about me beyond just the fact that I've been with the Watershed Resources Registry project since the beginning is, that I'm a certified climate change professional. It's very hard to say, so I'll just say CCP. I'm a biologist by degree. I like sun-kissed soda. I don't know if that's important, but I was told there'd be snacks, so I'm just throwing that out there. But just to kind of move us along, one of the things that I really wanted to talk about was not so much what we already know the WRR can do. I will go through that a little bit, but I also wanted to talk about the potential it still hasn't realized. So that's part of where I'm going to go with my discussion points today. So I think one of the things that I was talking about after that slide is, the fact that you guys covered what the Watershed Resources Registry already does. So what it grew out of for not just us at DOT, but in Maryland as a state and for the resource and regulatory agencies. And what I want to do now is really talk about what it could do still. What potential does it have that it hasn't quite reached yet? And to do that, I'm going to pivot, and I'm going to start talking a little bit about the application of the Watershed Resources Registry around climate change and resiliency actions. So one thing that transportation and government in general is really, really good at doing is creating reports. I'm not saying that they're popular and that people actually read them, but we can generate some good reports. So these are a few examples of reports that have been done in the same time frame as the Watershed Resources Registry development. So a lot of focus on climate change, how it affects transportation, and how we can adapt to make sure, and I'm going to go back to one of the words that I mentioned in the mission statement, how we can make sure that our transportation systems are sustainable. Next slide. Again, we are super good at making reports. This actual report slide is getting a little deeper into climate change hazards. So we went through the process of identifying the hazards that affect transportation. So you can think of things like the captain obvious things like sea level rise or storm surge, heat island effects, precipitation, flooding. Those are like the common hazards that we see. Then we started to do a little bit more of a deeper dive and look at the vulnerability of our assets. So in transportation, we consider our assets to be things like bridges and roadways, our transit system, rail lines, the electrical grid that we have in place to run our different systems. So we did some additional analysis on, how vulnerable is transportation to climate change, and where are we in terms of being ready for what's coming down the pike. Next slide. So I couldn't resist in putting together a slide that looks like a road, because I'm here to talk about transportation and climate change, but this also ties back to adaptive capacity and resilience. So within MDOT and within a lot of the DOTs right now, what we're doing is we're exploring the types of climate hazards that we have. And I think that one thing that I wanted to just mention, which is kind of a mind shift for us and is akin to some of what we were doing in the very early days with the Watershed Resources Registry, is, having an appreciation and an understanding of the interdependencies of the resource and the regulatory agencies and the regulatory programs. And for us, transportation we've always looked at it as, how does our transportation system impact the environment? So how do we affect water quality? How do we affect forests? That sort of thing. And the interesting shift that's now occurring across the globe really is, how is the climate impacting us? and how does weather impact us? It was never really as hyper focused on the externalities that could affect our life cycle of our assets, and that's happening more and more. So when we talk about climate change and climate hazards, it's from the standpoint of how often is this road going to be inundated? What's that going to do to our pavement integrity? What are the things that I could do that might help protect this and also ensure that I'm still providing what I'm supposed to be providing, which is safe and efficient transportation? So we take a look at existing known climate hazards, things like where mean high or high water is extending into the built environment. And then we assess our vulnerability and risk. So what you see on this slide, that red arrow is really indicating where we are along our road to adaptive capacity and resilience. And where I see this going for us at DOT with the Watershed Resources Registry will become clear in just a minute. So if you can go to the next slide, Dom. So one thing that we have, and I will share out a link to our MDOT Climate Change Vulnerability Viewer in the chat box here in a minute. I'm not going to go to the app itself, but what we've done is we have evaluated our bridges and roads throughout Maryland, not just our state-owned roads or state-maintained roads. And we've done an assessment to look at what the impacts of mean sea level would be based on a 2050 and a 2100 scenario. So it's about, I think it's a 2.1 foot sea level rise in 2050. And I'm going to get it wrong. It's probably around 6 feet for 2100. And what we did was we looked to see how many of our existing assets might be inundated in that time frame. And where do we need to try to focus our efforts on coastal resiliency measures, or where do we already see significant nuisance flooding in some of our local jurisdictions? And those sorts of images and GIS analyses are built into our climate change vulnerability viewer. Next slide. And then what we've done after we're adding some layer, doing some modeling, and Mike is familiar with the types of modeling that we did to generate the viewer itself. We came up with an impact analysis that said, well, we have 33 assets that are currently, and this is just for bridges across Maryland, and we have a number of bridges. We have almost 8,600 bridges in Maryland. So when you think about it in the context of all the bridges we have, 33 isn't so bad when you think about those that would be impacted by sea level rise. Storm surge, 172 of our bridges are vulnerable to storm surge. And precipitation change can impact 102 assets. And that may be because of localized flooding, scour resulting from erosive flows, those sorts of things. Next slide. And then what I wanted to show you is that these circled options here, investigating options and prioritizing actions, is really where I see the Watershed Resources Registry coming into play. And it's similar to what we were looking at when we first started the WRR, where it was coming from a place of mitigation for Clean Water Act program areas, 401, 402, 404, which Dom mentioned earlier. But now what I'm thinking is that there are co-benefits to our strategies, whether we're looking at doing, forest plantings for stormwater mitigation, and it's effective, in mitigating stormwater. It's got water uptake. It can also suck up some of the pollutants and nutrients that are impacting our Chesapeake Bay water quality. But at the same time, for our climate benefit, it can also help mitigate urban heat island impacts. It can also provide shading. It can have a benefit to other societal concerns within the context of the state of Maryland. So I think at one point, Dom mentioned, not wanting to double count, but and that still remains true. but I think that there's a fine line between double counting under a water regulatory program area and co-benefits of doing a project that can address water quality concerns, but also might have a carbon sink benefit that could help with air quality and greenhouse gas mitigation. So I see Watershed Resources Registry as helping us try to identify more specific actions around that co-beneficial environment. I don't know that that's the right word. Next slide. And I know that we brushed over this fairly quickly during Mike's presentation, but as Dom said, the three of us have been back and forth on projects for a long time now. And Mike and I have been working on a project that involves retrofitting stormwater ponds. And we have tied those stormwater ponds in using an adaptive control to open and close basically a valve that releases water out of stormwater ponds. It is linked to cloud-based weather data. It is run through a solar panel. It's super, super cool. So if you're ever in Maryland and want to go see these sites, I'm sure we could arrange for a little tour. But one of the things that we've always talked about with the Watershed Resources Registry is this concept of integrating real-time data. How can we take data from the cloud, whether it's USGS gauge stations or a weather forecast, and use that information to pre-release water out of stormwater ponds to maximize or optimize your capacity in those ponds and try to prevent flooding in areas where there's known flooding? And can you put those ponds with that adaptive control in a series so that you can have multiple storage units, so to speak, of stormwater ponds that can hold back those erosive flows and cause less damage to the communities around it? In terms of the USGS stream gauge data, one of the things that MDE, Maryland Department of the Environment, has recently been testing is looking at using stream gauge data to determine a threshold gauge height, a stage limit for the floodwaters, to determine when they need to be concerned about roadway flooding. And it helps with emergency response. It can help identify the detour areas that need to be taken to avoid the flooded roadways. And it can also help us track the flood path for community preparedness. So integration of real-time data within the WRR is something that we've been talking about. One of the things that we also talked about that I didn't put on this slide, but I'm going to say anyway, is a feedback loop. We've done a lot of restoration projects in Maryland, and the other states have done these as well. It'd be awesome if we could have some water quality data fed back up into the Watershed Resources Registry and start to see real water quality, watershed improvements demonstrated across our map, so that people can say, oh, hey, they've done 3 stormwater BMPs in this watershed. The nitrogen and phosphorus pollutant levels are going down. What else can we do that can help get us to a little bit better water quality? What would help augment that? Next slide.
And Sandy, I might mention that CMAQ, which for everybody, it's continuous monitoring, adaptive control. EPA actually provided some of the research background behind that. Hoboken has installed it.
Oh, did they?
It's in Hoboken, so it's also there. Yeah.
Yep, and that was probably the last meeting that I was at with Dom, real life in person, was that snowy day in Philadelphia back in March.
That's another one.
Exactly. So on this slide, I just wanted to talk a little bit again about what Mike brought up at the end, the tie into demographic information, adding mapping layers to the Watershed Resources Registry, making sure that we're doing actions, resiliency actions, climate change mitigation, watershed mitigation, that those actions are occurring in urban and rural areas and in the underserved portions of our different states. And having that tied into the Watershed Resources Registry is critically important. But we can also use the data to align with state targets. For example, in Maryland, this past legislative session, we had, I don't even know how many bills that talked about planting trees. I had a million tree initiative I worked on when we had a former governor in charge, and now they're up to 5 million trees they want planted in Maryland, which is fantastic. I don't know if we have the space for all that, but you know, we also have the ability to use environmental justice and equity census block data to help us determine where we can locate the 50,000 trees or 500,000 trees, whatever that sub goal is in these other areas. So I just wanted to mention that those were the things that I was looking at when I was asked to present out today on climate change. I really see that, you know, the WRR has been very helpful for us in Maryland, but I think it has a lot more that it can still provide. And I'm really excited to hear what you all, students, have in mind when you think about sustainability and how to leverage these types of tools. And I think I'll end there because my kids are home and it's kind of loud, so.
Oh, it's not the fair? I thought this.
No.
And I know that today's class, there was not time, there was a hard stop. Dibs, and you know, we're happy to follow up, you know, via email. Obviously, you can see there's a lot of facets to this, lots of opportunities, as we said, with today's technology and real-time